All right, so next up, we have the venerable Venkat Subramaniam. He really needs no introduction because he's just awesome. So take it away, Venkat.
Hey, Matt, thank you so much. I want to first of all thank all the organizers, so many people working behind the scenes, and also thank you for everyone who's attending. I want to talk about one specific class today, which is the collectors. I got really intrigued by collectors when I came across it, and I have to be honest about it. It is something that I've not still fully mastered, in my opinion, because there's so much to it. And so I decided to just devote a talk on just collectors itself. Before we get into the collectors, let's quickly talk about Java and functional programming. Well, one of the nice things starting in Java 8 was we could do functional programming with Java. Of course, with that comes our good old functions like filter, map, and reduce. So let's talk about that a little bit really quickly. Here is, let's say, a list of values we want to talk about. We'll call it numbers. And in this case, we'll say numbers is equal to, let's create a list of, what do we want to say here? Well, let's say list of numbers 1 to 10, if you will. Well, we want to apply some functions like filter, map, and reduce. So we could easily do that. As you would know, you could do some things like numbers, for example, and you could get a stream out of it. You could do a filter on it. Given an element, you could say, give me all the even numbers in the collection, for example. Then you could, of course, do a map on it and say, give me the double of the values. But the nice thing is we could also do a reduce at that particular point. We could say we want to start with the value 0 as a identifier in the beginning, and then of course identity in the beginning. And then you could say, for example, given a total and an element, maybe we want to do a total plus the element to get the sum of all the values in that particular collection. So we could use a reduce operation after a filter and map operation. Well, so reduce is a very common operation we perform in functional programming. Well, one of the things we need to keep in mind is collect is actually a reduce. So what does reduce really mean? Reduce doesn't mean a single value as in this example. It could be a single value like 60 in this case, but generally speaking, what I look at it as is reduce is an operation that takes you from a stream to a non-stream. So from a stream to an integer, stream to a list, stream to a set, whatever it is, you're offloading your results, getting out of the stream. And that's a reduce or a terminal operation at the point to complete it. So collect is a reduce. So when we think about reduce, sum and max and min and collect, all of them are reduce, something we need to keep in mind. When it comes to reduce, of course, how do we really take this collection of data, the double of the values, but let's say we don't want to total them, but we want just a list of the collection of this data. Well, this is where the collect function really comes in. Well, what we can do is we could use a reduce to do that operation, but that reduce will become really complex and very error prone if we were to write it. Well, thankfully, that reduce has been written for us already, and so we can do a collect as a function in this particular case. So when we call the collect function, what does a collect function do? The collect function can be instructed to do certain things for us, and this is where the collectors really comes in. And that's the utility class we're going to spend the next about 20 minutes on, just talking about that collectors. Collectors is a utility class which contains a collection of functions. But what's really intriguing about collectors is the nature of these functions. I will dive into this as we go through these examples. So what you can do here is you could say collectors dot toList, for example. And of course, I've statically imported the toList function, so we don't have to say collectors dot. So the toList is going to give us a list of those values. So you can see a list of double of the values, which are even numbers in this collection. But unlike the toList function, you could also do a toSet function as well. Just to see the difference between the two, let's go back here and put the 4 one more time here, if you will. Notice that 8 appears twice in this output, obviously because 4 times 2 is 8, and we got 2 occurrences of that. But we could ask it to give us not a list, but a set itself. So in this case, as you can see, it removed the duplicate values. Of course, sets don't guarantee ordering, so the order is also not the same as the input was. So we can do a toSet, we can do a toList. We can even do a to map, but we'll talk about that a little later. But wait a minute, though. Shouldn't we really be honoring immutability? One of the essence of functional programming is to really honor immutability. Now, why? Well, the reason is immutability is very critical for operations to be correct when it comes to functional programming, because functional programming heavily uses lazy evaluation. And in other words, code cannot be evaluated lazily in the presence of mutability. And that's one of the reasons why functional programming emphasizes immutability. But unfortunately, in this example, if I were to say integer, let's call it as a double of, let's say, even is equal to, and then I'm going to save this all into that variable. And I'm going to output right in here a double of even. Of course, I'll say a to list over here. So when I run the code, it gives us the double of the even values, which is great. And this is what we had in Java 8. But unfortunately, though, in the spirit of functional programming, we want to honor immutability. But what if we take the double of even and add maybe a value, let's say a 99 to it? Now look at the output. It's got that 99, which doesn't really make any sense. Well, what can we do? Well, this is where we could use an unmodifiable option that was introduced in, I guess, Java 9, if I'm not mistaken. And so this JDK has been enhanced to provide these kinds of functions. So what we can do here is we can change it to unmodifiable and then list, of course. Let's just comment this out for a moment and just run the code. It still worked the way it's supposed to work. However, if you try to mess with that list that was created, you will get a stern runtime error because it's an immutable collection and you cannot mutate it. You cannot change it once you create it. So moving forward, I would encourage you, even though the name is a little long than to list, to use the to unmodifiable list, to unmodifiable set, to unmodifiable map instead of to list, to set, and to map respectively. Those are better options. But what if I really want to take this collection and put that into two different groups? So for example, let's say we want to take all the even numbers on one side, all the odd numbers on the other side, which is a common operation we tend to perform when it comes to working with a collection of data. So what we could do here is we could say output. We could take the stream in here, but we could simply apply a collect on it. And again, keep in mind, collect is taking really a collector. So the collector is really a very fancy interface which gives us capabilities to perform some collection or reduce rather, collecting as in not a collection of data, but picking up the data and putting that into a certain form, a reduce operation. So these are really reducers. That's what they are, the collectors are. So the collector that we want to use in this particular case, earlier we used a to list, if you remember, or a to unmodifiable list. But what we could do instead is we could say partitioning. So a partitioning by, and we could provide to it a lambda where we could say mod2 is equal to 0, meaning we are simply telling it that we want to partition based on the even numbers. So you can see all the odd numbers on one side, all the even numbers on the other side. And that's a nice way to partition. And it doesn't have to be based on even and odd. It could be anything you want it to be. So for example, in this case, E is greater than, let's say, 5. And you can see all the numbers that are 5 or less is on one side, numbers greater than 5 on the other side. So you can provide a predicate, whatever the predicate is, and based on that, you can split them into two different pieces. And whatever that you want to split based on, you can do a partitioning, just split that into two, and doesn't have to be equal halves. Sometimes it could be something which doesn't have a value. For example, greater than 50, if I said, well, obviously no value is greater than 50, everything piles up on one side. So that's basically partitioning. Well, that's all so good so far, but the collectors is something that's absolutely powerful. Like I said, it's a particular utility class. You can spend quite the amount of time with it, and there is so much to learn. And when you're done with it, you'll find there is so much more to learn. In fact, I would say collectors is really a wonderful class to spend your Saturday night with. If you really are bored, don't know what to really do, you're sitting there and scratching your head, well, just go ahead and invite collectors. You'll have a wonderful time with that utility class. So that's basically what collectors are. But let's look at one other capability of it. But for this, let's switch over to a slightly different example in this case. So let's bring in a collection of, let's say, a people object. Just for our purpose in here, let's bring in a collection of people. So this is going to be a bunch of person object. We got people with the same name. We have people with the same age as well. That's basically the collection of data that we are dealing with. So I want to work with this collection. So let's go ahead and say people is equal to create people. We'll just save that into this people variable to start with. Now, what I want to do here is we will say, given these people, we'll say print their names, let's say in uppercase, let's say comma separated. Now, how would we do this? Well, you may say, gosh, we've done programming and imperative stuff for a long time. This should be really easy to do, isn't it? So we could say person, and we could say this comes from the people collection. And we could simply say output person.get name. After all, it shouldn't take a really hard time to get the names. Oh, but the problem says in uppercase. So we could say to uppercase right here. Hey, that's not a problem after all. We can just get the names in uppercase. That was very easy. But it does say we should really print it comma separated. So we could simply say plus a comma to separate them by comma. And of course, the intention was for all of them to be on the same exact line. So when you run this code, of course, ta-da, you got the output. They're all on the same line. But wait a minute. Notice there is a stupid comma in the very end. Have you ever seen that problem before? Of course we have, isn't it? And how did you feel the first day you ran into it? You were in denial this was happening, isn't it? Because it turns out it's not so trivial to remove that comma. You may say, gosh, that's not really hard. Somebody may tell you, put it into a string and remove it. Oh, darn it, strings are immutable. Well, maybe we can use a string builder, you think. And your colleague is like, is it string builder or string buffer? Now we have a 30-minute discussion on it. And then somebody tells you, oh, it's really simple. All you have to do is simply do for int I equal to 0. And of course, you know, this is never going to get us home on time because it only becomes a much bigger mess. Well, simple problems have to be simple to solve and complex problems should be really affordable to solve. Well, this is really a simple problem. We shouldn't sweat so much on it. So output, again, we can say people.stream, and we can simply say over here map, and given a person, get me the name of the person. Great. Now I want to perform a map given a string. I want to convert it to a to uppercase. Nice functional transformation, as you can see. Then we perform a collect, and comes our friendly collector one more time. And then we say joining, and then we can simply ask it to join with a comma, as you can see. When you run the code, we got the output we desire with no stupid comma in the end. This is how coding should be, really, isn't it? And again, this joining is a utility function that returns a collector, which knows to collect this data, the output, into a string, comma separated very nicely. All right, those were really simple things. Let's up this by a notch. What about grouping? Now, going back to this example, you will notice that the collection has people with different names on it. We got Sarah, Bob, Paula, and so on. Maybe what I want to do is to group them all together. I want to group all my Sarahs into one group, all my Pauls into one group, all my Bobs into another group, all my Jack into another group. Sorry to use the word, I want to put them into different buckets. That's exactly what you want to do. You want to take every person and put them into a bucket based on the name. So how do you really do this? If you want to do this in the imperative style, it'll be really, really hard. Let's just go through a mental exercise. Hey, take Sarah. Do we have Sarah as a key? Well, we don't. Let's create a key Sarah. Let's create a list for that. Add person Sarah to the list. Next one. Oh, it turns out to be Sarah. Do we have Sarah in the key? Oh, yes, we do. Get the list and append this person to that list. How would you do that? Well, that looks like a lot of effort, isn't it? How do you write code with a lot of effort? Well, that's why you hire the interns, isn't it? No, just kidding. Poor interns, you want to give them fun things to do, not really these kinds of boring jobs. Well, what if we can use a very fancy, powerful API to do exactly that? So let's give it a try. So what we can do here is create a map of a string, but the result is a list of person. That's what I want to really do. By name is equal to, and we can say people.stream. And now we can simply say dot collect. And once again, when we are done with it, we will simply output the by name as an output right there. So what are we going to do in the collect? We're going to say grouping by, and given a person, I want to group it based on the name of the person. So that's basically what I want to do. I want to group based on the name of the person, and that's basically our intention here to group it. When you look at the output at this point, notice Bob is in Bob's bucket. The two Sarahs are in the Sarah bucket. Jill is in the Jill bucket, and the Jack, and you can't see the rest of the output on the screen here, are in the Jack bucket. Well, that was not really hard at all, isn't it? And of course, you can shorten this a little bit further by using a method reference as well, very easily, as you can see, and you can very much write that grouping. Well, that's great so far, but you know what? It's obvious that Bob is in Bob's bucket, Sarah is in Sarah's bucket. Maybe I don't care about the full person object. What I really want to care is, maybe I want to store their age value. Well, somebody corrected me the other day and said, if I want to store the age, it better be a long. Well, I kind of appreciate that sentiment, but in this case, I've kept it as an integer. So in this case, of course, it's a integer. So what do I want to do? Well, I want to take the Bob or a Sarah or a Paul or a Paula. I want to put them into a bucket, but not the person itself, but I want to take the age and put that into the bucket. Hey, what is that? That's a transformation. What is another word for transformation? Mapping. Well, that's exactly what it is. So we're going to say comma mapping, and based on a person's get age, and of course we want the result to be a list, and so we are asking it to give the result into a list, as you can see in here. So when we run the code this time, oops, what did I do here? A little bit one too many parentheses, I suppose. So in this case, of course, when we finish this, we can see our one less. So we can run the code and we can see Bob 20, but Sarah is 20 and 22, and Jill is 11, Jack is 3 and 72, and so on. So we perform the grouping, but we perform the mapping. I want to pause right here, and I want to observe something which is easy to miss, but quite nice if we really get a hang of it. I want you to notice this very closely for a minute. This is what we had a few minutes ago in the beginning. So what we had a few minutes ago was that. Now notice that grouping, what is grouping returning to us? Grouping is returning a collector. Well, that's great. But notice this grouping, which is returning a collector, itself takes yet another collector as its second argument. So this blew my mind, because you can create a collector using a collector. Now, obvious question there is it possible for that collector to use another collector? And the answer is yes, because we already see that, because you know that toList is a collector too, because we use that as an argument to collect earlier on. So you can take the collector and build a bigger collector, in turn build a bigger collector. You get the hang of the recursive structure here. A collector can form a collector can form a collector. Well, the only end to it is keeping ourselves sane at some point and say, we're done. We don't want to get any further with this. So that's basically an example of how we are able to use the mapping. Now, clearly, in this case, we can do a lot more than simply performing grouping and mapping. Well, let's take an exercise for a minute. What if I really want to find out how many of my friends have the same name? Now, if you're really bored on a Friday night, you could go through this exercise. You could think about all your friends. I'm sure you have a lot of them, and find out what their names are and how many of your friends have the same name. Well, this kind of blew my mind because I one day sat back and thought about it. And then I quickly realized that I have, a lot of friends, thankfully. I'm very happy for that. But it turned out a lot of my friends have the first name as Brian. I don't know why. And every other friend seems to be having a name Brian. If somebody comes to me and tells me these days, hey, Venkat, can I be your friend? The first question I ask them is your name Brian? And if they say yes, I say, I'm sorry, it's taken. Well, you can just find out a count of how many of your friends have, the same name. Well, wouldn't it be nice to group them into that? So here's an idea. Let's take this and say we want to create a map of a string, but the result is an integer. So a name, value, a dictionary, a map, but the name is the key, but the value is going to be the count of the number of people with that first name. So we're going to say a count, let's say by name is equal to, and when we are done with it, we want to output the count by name. So how do we really count based on the name? So what we can do here is, again, keep in mind that bucket we talked about. So we are going to say people.stream, and let's bring in the bucket. So collect, and we can then say a grouping by, and this is going to be a person's get name. So we got the person's name. So we are taking every person and saying, oh, Brian, go into that bucket. Oh, Paul, go into this bucket. Oh, Sarah, go into this bucket. But rather than putting the person into the bucket, we earlier saw how to put the age into the bucket by doing a mapping function. But we don't want to put the age also here. But what we want to do is we want to count the number of person and then put that result into the bucket. So in other words, we don't want to put the object into the bucket. We don't want to put the age into the bucket. We want to put the count of the number of objects into the bucket. So this becomes a counting, but it turns out counting actually gives you a long value. So that's basically what we are doing here, is asking for a counting. So when we do a counting, it's going to tell us that how many elements exist of that. So when I run the code this time, there's only one Bob here, but there are two Sarahs, as you can see. There's one Jill, but two Jacks, one Paula, but two Paul as well. You get the point. But wait a second, though. This is a long. Well, I was working with an application where my function that I had in my API was expecting an integer value. Well, this one was giving a long. And I was like, gosh, how do I go from a long to an integer? And then, of course, when you take the value, you can call another function, perform a casting, and send it. But that's very smelly. Even saying it really begins to smell bad, isn't it? So what I really want is integer, but I want to make it really elegant to do it. How can I do it? Well, remember this principle of the collectors being recursive, about collectors having collectors. That's exactly what we are going to do. So there's a collecting and then that we can use. So what we can do here is we can say collecting and then, and we can take the counting at this point, and to that we can say long and provide an int value and ask it to convert that to a integer, as you can see in here. So as a result, now you are not going to have a type conversion issues. You have an integer conversion. Just to illustrate the point that it really did the job, if I said long over here, notice we get a compilation error, type incompatibility. If I said an integer here, that one actually worked. And again, on the same note, if I were to take that away from here, And then if I were to simply say counting, you would notice that that gives an error as well, because you cannot put an integer. That's got to be a long at this point. But if I really wanted an integer, I would have to then perform that operation. But again, the recursive structure really shines. So if there's one thing I want you to take away from this, I want you to keep in mind that collect is reduce. Okay, more than one thing. Collect is a reduce, and collect is taking a collector, and the collector itself, the collector's functions, which is what we are focusing on this discussion, is actually a set of utility functions, but these functions themselves form a recursive structure of collectors. You can build a collector using another collector, which in turn can be used to build yet another collector. And that is where the real fun is. And after talking about all of this, I still feel I have merely scratched the surface. Like I said in the beginning, I don't really think I can say I've mastered collectors, because collectors is so intriguing. It contains a wealth of these functions. And this is an exercise you can go through. You can take a particular problem, write the code imperatively, write it in a functional style, and then come back and refactor it to the elegance and the concise nature of collectors. And of course, it'll be a hard journey because it can get a bit complex. These are, take an effort, but when you have it working, it does feel quite rewarding, as you can see here. Hope that was useful. I'll be delighted to take some of your questions at this point.
So thank you, Venkat. That was excellent as always. We have a couple questions. The first one is there a workshop or course you'd recommend to learn more about collectors and get hands-on experience using them?
I'm sure there are plenty of courses out there. I spend a lot of time teaching such courses in the industry as well. I don't have anything off my head to really refer to, but I would say search on the web.
So one of my favorite questions, I saw this from when you spoke earlier, is what IDE are you using?
This is TextMate. So if anyone is interested in looking at it, go to agilelearner.com. And there's a search box, just type the word TextMate on it. I show how to set this up for Java, Python, Groovy, JavaScript, so multiple different languages. If you're not able to find it, drop me an email or simply ping me on Twitter. I'll be more than happy to send the link.
Cool. Maybe you could drop that link into the Slack channel for the Track Java as well?
Sure.
All right. So that was awesome. I really enjoyed that. I think we're ready for Brian to step in.
Yeah, all right. I've got one more question for you, Venkat. In one of your examples, you were using the map function to get the first name of the person, and then you use the map function again to get it to uppercase. Why not combine these two?
Oh,
and
wonderful.
what is...
Yeah, awesome question. So premature optimization is the root of all evil. We've been told by a very wise man, isn't it? And 40 years later, we try every day to disprove him. The reason I want to keep them separate, Brian, that's a really good question. And the reason I want to keep them separate is twofold. One is, if you put them in one line, that's called lack of cohesion in software development, isn't it? Cohesion is where a piece of code is narrow, focused, and does one thing and one thing really well. So by keeping them in two different lines, it's more cohesive. Secondly, I'll illustrate with my hand here. If you have these lines of code, it's easy for me to remove a few and bring back a few into it. So this becomes easy to maintain the code when they are separate lines. If I combine them into one, that's more expensive, more effort to really modify it. So keeping them separate is better. So from the code maintenance point of view, code is cohesive, easier to change, easier to maintain. Of course, the P word, what about performance? From the performance point of view, we also benefit because internally, those functions are fused together. So we don't lose any performance internally. We get the benefit of maintainable code outside. So that's the reason it's important to keep them separate.
So in general, you would say you prefer to make them or to keep the function small and use map and filter multiple times if needed.
Absolutely. It's not a preference. I would actually insist on it.
All right. Thank you. I think that is very useful. And with that, Venkat is basically, the last one on this part of the Java track. Within a few seconds, the stream will move over to, if I'm not mistaken, Simon, and Simon will host Baruch, who will do the next session. So for now, I want to sincerely thank you, Venkat and Matt, for hosting the last few hours here on the Java track. It's been a delight working with you, and I think we had a lot of great content and a killer end with your talk in the end, Venkat. So thank you so much for watching, and we'll be back in a sec, or Simon will be back in a second. Thank you so much. See you later.
See you all. It's great working with you.